Okay, class. Today we are talking about RAID. And despite what you may think, that is not a bug spray when we're talking about computer speak. In computer speak, that means joining two drives together, taking the potential of two drives and making it one. So the computer sees one drive, but there's actually two disks performing the strength and function of that drive. So what that means is adding the bandwidth of another drive or making a redundant copy of that drive for fault tolerance. So kind of picture it as two big guys pushing a car. One big guy can push the car, but two big guys can really get in there and get that thing moving. Now picture if we could take those two big guys and make them into one great big huge guy like the Hulk. Then he can push the car real fast all on his own. So that's what we're doing, is we're taking the maximum ability of each drive and combining it to be one powerful drive. Something that you guys might have grown up with that will be kind of nostalgic for you might be this.
Good. Your energies are aligned perfectly. Now perform the technique. Whoa! That is amazing!
Yeah, and on their first try, too!
Yes, it's an impressive transformation, but I'm very curious about your control.
That's the combining of two things to make one really powerful thing. So again, in RAID, that's combining the potential of two drives. We're going to start out with different types of RAID. And the first RAID we're going to use is RAID 0. RAID 0 is taking the bandwidth of two drives. Like if this can push this much and this can push this much, together they can push this much. So they're able to, when there's a read command, they can push twice as much data back. So that's faster response time for video games, first-person shooters, things like that. So it's predominantly used by gamers. One of the setbacks of RAID 0 and how it works, actually we'll say just some of the abilities of it. To be able to push the maximum amount of data, every other piece of data goes to the drive so that each one can push different data at the full speed. Like if we took my initial, R, and we split the letter R up into two parts, they don't mean anything by themselves, but pushed together, we get the R, and that makes sense. The problem with this is if you lose one drive, you lose your data. You lose everything. But it's really fast. The next type of data we want to talk about is RAID 1. RAID 1 means mirroring. It is a backup copy made at all times of what's on the first one. It's not a separate copy. When something's written, it's written to both drives at the same time. And if you lose one drive, you've still got all your pictures, your emails, your videos, everything. And when it writes like this. The same piece of data is written to both drives at the same time. Now, if you lose one of these drives, you still have everything. You're still good. So, you might ask yourself, if I had a choice to have fault tolerance, mirroring, or speed, what would you choose? A good answer might be this.
I say, is it too much to ask for both?
The way that you can get both speed and fault tolerance is to do RAID 5. RAID 5, you have two drives that are striping, which is your maximum speed, and one drive that is checking the differences between the two drives to figure out what's there in case one's missing. So we'll call that the parity drive. So we get our 1 and our 0 and a parity bit. Now, how that works is we've got 1, 0, and if these two are different, then this is a 1. If these two are the same, then this is a 0. See how that works? Alright, so if this drive was to disappear, and we lose this data right here, if this one's a 1, and this one says that they were different, we know that one's a 0. If this one's a 1, and this one's a 0, which means they're the same, we know that one's a 1. Now, because there's math going on, there's some complexity, and that takes away from some of the speed. So you don't get the same speed as two drives striping each other. It's about 1.5 because of that math and complexity that's going on. But you do have an increase in speed, and you do have data redundancy with only 3 drives. Now, if you want the best of both worlds with speed and redundancy, then we go to what's called RAID 10. That's RAID 1 plus 0. And that takes a minimum of 4 drives. And what we do is, RAID 1, remember, is a mirror. We'll represent that like this. Both of them have the same data on them, A's or 1, 1, whatever. And we'll have another RAID 1 array, and that's got different data on it, like zeros, zeros. And then what we're going to do is we're going to stripe those two so that they're both pushing different data as fast as possible. So we're going to make a RAID 0 array. Out of those 2 arrays. So when we make these an array, Windows sees this as one drive. It sees this as one drive. And then we're going to combine those together so Windows sees this as one big array. However, since 2 of them are doing redundancy, then we're only going to get the speed of 2 of the. We're only going to get the size of 2 of the drives. So if we had terabyte drives, 1 terabyte, 1 terabyte, 1 terabyte, 1 terabyte, then we're only going to get 2 terabytes, but we're going to get some wicked speed. Okay, so for review, 2 drives using the maximum bandwidth but no safety is RAID 0. 2 drives making a copy of each other, being written at the same time, every time something's written, that is mirroring, and that's RAID 1. Striping plus parity. Now remember, parity means math. That's right. So striping plus parity is RAID 5. Again, remember, anytime you hear parity, that means math. Now, RAID 1 plus 0, or RAID 10, is 4 drives. Maximum speed, maximum redundancy, but you lose a little bit in size. Now, this is okay if you can afford it, but if you can't afford it, you can always go to the RAID 5 and drop off the price of one of the drives. Got any questions on those? Anybody? Okay. At the end of your row, there's a stack of sheets. It's a self-test. What I want you to do is go through here and answer some of these questions. Like one of them says, Windows will show a single 200 gigabyte drive when 2 100 gigabyte drives are used to create what kind of array? Well, if you have two 100 gigabyte drives and it shows 200, then that's got to be no redundancy because you're seeing the size of both. So that would be RAID 0. Windows will show a single 200 gigabyte drive when 3 100 gigabyte drives are used to create a what kind of array? Remember, one drive. So if we have 3 100 gigabyte drives, but we're missing the size of one of those, we can figure out that one is doing the redundancy. So 1 drive doing redundancy, 2 drives doing striping, that must be RAID 5. Okay, any questions? All right, great. When you're done with those, go ahead and turn the paper over and make sure that you add what we've said so far to your notes. When you're done with those, anybody has any questions, you can come on up and ask me.